Okay, everybody, we're going to conclude our chapter 25 discussion of carbohydrate with an exploration of disaccharides. There are 4 you need to know. I'll give you a Cliff Notes short form summary of the 4 you need to know. You got maltose. Every disaccharide involves at least 1 glucose. That should help you. Glucose, alpha 1 to 4. I didn't write that the way I wanted to. Alpha 1 to 4 of a second glucose. I like to remember maltose with something called cellobiose. They're the same except for the alpha and beta switch. That's the only difference between cellobiose, which sounds like it's related to cellulose. Why do you think it sounds like it's related to cellulose? Because it is. It's the dimer that if you keep growing it in a repeating fashion becomes cellulose, called wood. Cellulose is wood. It's the precursor to wood. And we can't eat wood. Why? Because the glucoses are hooked up beta. We can't digest beta-linked glucoses. Okay? And you think there's some organisms that can, right? Can you give me an example of an organism that can break down beta linkages between glucoses? No animals you know that can eat wood products and get nutrition? Carpenter ants, good example. Termites. Actually, we're both wrong, you know. It has nothing to do with carpenter ants and termites. It has to do with something called symbiosis. The carpenter ant, cows do it too. Cows eat grass, right? That's cellulose. It's not the cow, though. How does the cow eat grass and get nutrition? It's not the cow. Anybody? It's the bacteria inside the cow, living with the cow. It's called symbiosis. You're going to learn about it someday. Okay? And that breaks down to glucose, your cellulose. Okay? And there's 2 out of the 4. And then I'll go to lactose. I put it under cellobiose for a good reason. I'm going to copy cellobiose's description. And guess what one of the sugars is changed to? Based on the name lactose. Which of the monosaccharides has LACT in it? That's your assignment right now. Galactose is hooked up beta 1,4 to glucose. And a lot of people can digest it, but a lot of people have trouble for the same reason nobody can digest wood. We have trouble with beta linkages being digested. We need a special enzyme called lactase. And some of us, we haven't used that enzyme a lot over generations. This has to do with culture. So certain cultures that didn't use their lactase enzyme very much lost it. And now they are lactose intolerant. Okay? And you can buy milk that has lactase in it. I think they call it Lactaid. There's my promo. I should be getting a kickback now. They just put the milk with the enzyme in it, and then you use the enzyme to digest it. So you don't get the bacteria digesting the lactose after it leaves your stomach. And I don't want to tell you the side effects. Anybody that's lactose intolerant can tell you it's not fun. Anyway, our 4th disaccharide, 4th, is called sucrose. It's got a glucose in it. Yeah, easy to digest. So no surprise it's alpha, but it's not 1,4 to another glucose at all. 1 to 2 with fructose. Yeah. There's your summary of all the disaccharides. You'll see pictures in the notes. So we're going to do glucose alpha 1,4 with glucose here. Glucose alpha 1,4 with glucose. Up at the top. And I tell you, this is the question where knowing your chairs is going to save you a lot of time. I'm not going to do any of the steps. I'm going to draw me some nice chairs, parallel lines, all that good stuff. Put all the groups on or equatorial. I don't have to darn right and up left and all that good stuff. Alpha is going to be down. That's carbon 4's oxygen from the other sugar. How do I know it's carbon 4's oxygen from the other sugar? Because it's hooked up 1,4 with another glucose. Carbon 4 is here. You're going to copy everything except for the H on that O, because that O is already drawn. So here it is. Parallel line. Parallel lines. Equatorial. And it says to draw beta maltose. This is where I'm going to use a highlighter. This is the variable. It could be alpha or beta maltose. And beta means cis to the CH2OH over here in the ring. There you go. Groovy. Nice. This here is called Tollin's reagent. Will only oxidize. This is a new thing, but all you need to know about Tollin's reagent is it oxidizes aldehydes to carboxylic acid. That's all you need to know. And I just want to Benedict, which is CuSO4AQ, does same as Tollin's. Okay? They're old diagnostic tests for seeing if you have a hemiacetal. If you have a hemiacetal, it'll react. If you don't, it won't. So over here, acetal won't react. It's shut down. It's on lockdown. Hemiacetal over here reacts. What's it become? Carboxylic acid. What's a carboxylic acid look like at pH 11? Sorry, 11. It ain't a carboxylic acid. If your pH of the environment is above the pKa of an acid, the acid will lose its proton. High pH deprotonates acid. This should make sense. Please don't draw a carboxylic acid when the pH is above 5. If the pH is above 5, the carboxylic acid loses its H. So I'm going to draw a carboxylic acid here. This is going to be liberated as its alcohol that it was before. So please use R's judiciously on your exam. That doesn't change. Acetals on lockdown. R is connected to the ring. not a ring anymore. I shouldn't stress out too much. That's an OH. It got liberated when this thing opened up. And just gotta make sure I have my other OHs in here. And I told you this becomes a carboxylic acid, but not at pH 11, it doesn't. And green. The only reason we learned about pKa's is for this end of this semester. Wow, what's the hint here? Plus 1 point. Makes mirrors work. What makes mirrors work? What kind of a hint is that? What is a mirror? Yeah, you look at a mirror and you see your image, right? Why is that? What are you looking at? You need to have a substance that reflects light. What substance is that in the mirror? No, the glass doesn't. Oh, mirrors would be a lot lighter and a lot less expensive if it was just glass that you needed. Those mirrors are heavy. You ever lifted a mirror? Compared to a piece of glass the same size, it's at least twice as heavy. Because that's not just glass. What is on the glass that reflects the light? Oh, please no. That would be a workable mirror, but you said mercury. Yeah, mercury reflects light, but there's no way mercury metal is going to stay on a piece of glass. It's going to flow down and make a puddle. Mercury is a liquid metal. What other substance looks like mercury? In fact, mercury is named after this other substance. Did you know that? What's the symbol for mercury on the periodic table? Hg. Okay, what's this? There's another symbol that ends with a G. Ag, which is silver, and Ag is called argentium. That's Latin. And mercury is flowing silver or silver water. Hydro is water, right? Hydro. Hydroargentium. Hg. That's where it got its name. Old name was quicksilver. It's silver that flows away. It's a liquid. Don't use silver for your mirrors. And it's nasty for you, right? Mercury. It's silver. Metallic silver. Can't be silver plus 1. That's not silver colored. It's not at all. Yeah. And this is how you make a mirror. Maltose is pretty cheap. You build a box out of glass. 4 sides to a box and a bottom. That's 5 pieces of glass. You fill it with a solution of maltose, like 1%. They use a cheaper one. I believe they use formaldehyde. It's got an aldehyde, right? What does Collins reagent do with aldehydes? It oxidizes them. What's the side product? It's in the little box. Silver. Where's it go? It goes on the glass by itself. It precipitates on the glass and makes a nice thin film. You've just made 5 mirrors. Rinse, dismantle the 5 mirrors, put frames on them, sell them. You're done. We have 2 questions. Yes.
Wait, why does the Ag happen?
Because it's not an ion of silver that you're used to. If it's silver, you can leave it Ag with no symbol or Ag with a 0. They're both okay. But you better show me you know it's not an ion of silver. It's a redox reaction. Silver used to be +1 and it got reduced. Carbon used to be only 2 bonds to O, now it's 3. It got oxidized. So there you go. Now, alderic acid, and there was some hints. A monoalderic acid. What's mono mean? Just 1. Alderic. Do you remember which ones are alderic? Yeah, only the top carbon number 1 of the aldehyde got oxidized. And I think I can do myself a big favor. Wasn't this carbon number 1 here? And it became this, which is an aldarate. Conjugate base of an aldaric acid. Why don't I use my circling tool? Orange, never use orange. It's going to be identical. Oh, I didn't want to circle the O though. Call that R prime. So R prime is connected to the green O, which has an H on it now. Okay. And you can't make this into an acid. That's locked. So it didn't change all day, did it? It's still part of this, still part of this, because this has got R in it. Monouronic acid, and basically, I want to be able to copy this again, right? Uronic acids, where was the carboxylic acid? Was there 1 or 2? Just on the bottom. Thank you. So this is the bottom right here, carbon 6. You could have made it from this one as well, but you're going to have more drawing to do. It just says you pick which one. There's one here and there's one here. I'm going to pick this one because I copy my pink R. And oh yeah, R goes to here. And parallel and parallel and parallel, parallel, parallel. There's an O up there. This becomes a carboxylic acid. This didn't change. And what do we have here? OH. We can keep that too. There you go. Just carbon 6. 6, 5, 4, 3, 2, 1. Just carbon 6. And that is disaccharides. Big picture coming up. Not letting me. Oh. Oh. It's on the. Okay. Crossing your fingers helps sometimes.